Hello, my name is Carolina Vázquez Ralis, and I'm going to explain to you my mathematical thinking problem situation. Okay, so we were giving a series of information from Cisco company. We received sales information from 10 different years. So here we can see the 10 years, and here we can see the sales obtained in each of those years, and they are written in millions of dollars. So how can we solve this linear regression problem? I'm going to go ahead and delete my graph for a minute to show you how to do it. So we are going to select this year and sales columns. So the year column is going to stand for the X values, and the Cisco sales column is going to represent the Y values. So we're going to click on Insert, Graphic, Scatter Plot, and here we have it, okay? I like this blue better. So how can we find our equation and our parameter? So we're going to go ahead and click on our values inside the graph. We're going to click on Add Trend Line, and we are going to add the exponential one. Now in options, we are going to check the box for presenting the equation in the graphic and for presenting the R value in the graphic. Okay, so here we have it. We have our graph, and we have our equation and our R squared parameter. Okay, so now how can we find the sales estimations for the company? What we basically need to do is just substitute our equation, and the only thing that is going to change is that it is going to be multiplied by X, which in this case stands for the years, okay? So that's the only thing that's going to change. So here we can see 58.553 exponent 0.5694 multiplied by X, which in this case is the 1. And we basically just need to drag it all the way down, and we are going to get all of our sales estimations, okay? So here we go. Now, how can we determine the function that presents the best fit for the presented data? Well, in this case, we can obviously see by our graph that this is an exponential function because it is exponentially increasing. So when we insert the trend line, we have to make sure that we insert the exponential function 1. So we are going to get the actual accurate function and the actual valid parameter, okay? And furthermore, this function generated has a power of X and uses the Euler's number, which is also a key to determining that it's an exponential function. And this type of function has the least margin of error according to the coefficient of determination, or R squared. So, as I was mentioning before, we can find that R squared is our valid parameter, as it is used to analyze how differences in one variable can be explained by a difference in a second variable. The range is measured from 0 to 1, and the closest it is to 1, the more equal they are. In this case, we can see that it is a 0.98283, which has a very slight difference of 0.01717 of the actual value of 1. So it's pretty accurate. And lastly, do I consider that a better prediction could be done? Yes, definitely, a better prediction could be conducted, but only if we received more data, either specific data from monthly, weekly, or daily sales within a year, or more sales data from other years. So if we receive more data of sales from each year, all of these dots will be a lot more together, and this will mean it will be a lot more precise to calculate and to estimate. And furthermore, this exponential function doesn't take into account the possible deceleration in the company's growth as the years go by. So here we can see that the sales estimations are actually, for example, in this one is higher, and then in the second year it's a little bit lower, third year a little bit lower, a little bit lower, 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 still lower. But then in the 9th and the 10th year, we can see that the sales estimations are higher than the actual sales the company had. So here's what I'm talking about, that this exponential function model is not taking into consideration other factors. Thank you very much.